right, hopefully this is going to be a real short video on day one. Sorry I'm not there in person with you, although I'm sure you're not sorry that you're not at school. So let's dive right into it. Hopefully it's a quick little video about Unit 9. The upside of Unit 9 is that some of it is familiar and some of it will be unfamiliar, and it's always good when you're building unfamiliar concepts, but it doesn't really have anything to do with like systems or inequalities or anything like that. So we're kind of moving into some new territory. So let's just start with the pizza example. You got a friend coming over, you and that person really love pizza, so everybody gets their own pizza because, you know, why not? So we've got 2 pizzas to start with, and now, you know, each of you call a friend, and so now everybody invited a friend over, so we're going to double the amount of people that we started with, right? Like we had this person, they called a friend, they get their pizza, and now this person called a friend, and now they get pizza, so we just doubled the amount of pizza, right? So if we double something, it means to multiply it by 2, which makes sense because 2 times 2 is 4. And notice we have obviously 1, 2, 3, 4 pizzas, right? But let's just say each of those friends makes another call, right? And so now every person gets to invite one more person. So this person gets a buddy, this person gets a buddy, this person gets a buddy, and this person gets a buddy, right? So we had 2 pizzas. We doubled it. That first person made this phone call. The second person made this phone call. And then we doubled it again, right? So what does it mean to double? I'm just going to keep multiplying it by 2. And let's just see if this matches up. 2 times 2 is 4, times 2 is 8. So my prediction is that there's 8 pizzas. So we've got 1, 2, 3, 4, 5, 6, 7, 8. I'm not wrong, so that's great. We can do this again, and we can double it again. And my prediction is that if we double it again, we'll get 16 pizzas. Now, I don't want to make 16 pizzas show up, but what we would essentially be doing is making 4 rounds of phone calls. We'd be taking our original 2, doubling it, making another round of phone calls, making another round of phone calls, and there's your 16, right? So we could do this over and over and over again if we really wanted to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 blah. But that's just me making more and more phone calls, inviting more and more friends. And so that seems really annoying to have to do this and 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 this. And there's actually a shorter way to write this. Just like in inequalities, your solutions being less than 12 is a lot of words to write, where I could just write this instead. I like that a little bit better. It's shorter and less time consuming than words, but obviously everything has pros and cons. So if I want to multiply 2 times 2 times 2 times 2 4 times, instead of writing 2 times 2 times 2 times 2, there's a shortcut way of writing it, which is 2 to the 4th. All right. And that's our next unit. So that 2 to the 4th comes with an understanding that that is an exponent and this is a base. A base is what the exponent is attached to, and that can be really, really important. So let's start out with some basics, pun intended. Okay, so let's figure out what this means and what it doesn't mean. 5 squared means that the exponent of 2, and exponents are teeny tiny numbers up here, it tells us how many multiples of the base you have. So 5 squared literally means 5 times 5. See, I copied the base twice. And then we can do that. 5 times 5, obviously we know is 25. So I can go around telling people I'm 5 squared years old, or I can tell people that I'm 25 years old. I'd be saying the same thing, right? Okay, so we can make it a little more complicated by changing the base. We can make it x squared instead. And what that would mean is that I would have 2 copies of x being multiplied. Remember, the base is what's being multiplied, and the exponent is how many times that happens. So x squared would mean 2 copies of x multiplied. And that's, again, x squared. There's no other way to write that. Again, let's make it a little bit more complicated. What if I had 5x squared? What does that mean? Well, be very careful. That tiny 2, that's the exponent. It's attached to the base, and the base in this case is that x. So I have 2 copies of x, right? That's what that looks like. but only one copy of that 5. So that 5, where does it go? Well, we just bring it to the front. So we've got a 5. There's a secret times symbol there, even though you don't see it. When 5 and x squared are next to each other, it really means 5 times. So what we have is 5 times, and x squared means 2 copies. So if I had 7x to the 4th, that would be 7. That is not the base. It's not the thing that's attached to the x to the 4th. But it can't just ignore it, so it has to come along for the ride. And x to the 4th would mean this. So if the 7 is not the base, what do we call it? Well, we can call it the number out in front, which we do sometimes. But the third new vocab word that you might be aware of is a coefficient. So if there's an exponent and a base, and there's only those two objects, there's nothing really out in front there. This doesn't have a coefficient. The coefficient's missing. If you really wanted to be extra specific, you could write a 1 times there, but no one would ever do that. That's just unnecessary information, right? So if the exponent and the base do have something in front, then that would be called the coefficient, and it only comes along for the ride. It doesn't actually get that 4. Okay, hopefully that makes sense, because I'm going to make it a little weirder. So what happens if I change that problem a little bit more? What happens if I get something that looks like this? So now you have to ask yourself, what's the exponent and what's the base? The base is the thing that's attached to the exponent. In this case, the exponent, the 4, was only attached to the x. So there was only 4 copies of x. In this case, the exponent's still 4, but the thing that it's attached to is 2x. Those parentheses make all the difference. So what this really means is that there are 4 copies of 2x. A 2x with another 2x with another 2x with another 2x. And then all those things are being multiplied, copies that are multiplied. So if I multiply x times x times x times x, there are 4 x's there. So the short way of writing x, 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 x is x to the 4th, right? 1, 2, 3, 4. But we would never write 2 times 2 times 2 times 2, although we could. And then I could put the x's back here if I really wanted to. Right? If it said 2 times 2 times 2 times 2, what we would really do is 2 times 2, just 4, times 2, 8, 8 times 2, 16. So when you are what we call expanding these, so we took this 2x to the 4th and we expanded it the long way, we made 4 copies of the thing that it's attached to. Same thing that we did here, 4 copies of the x with 1 7 out in front. All right, so when you do that and you expand them, then you're going to try to simplify it one more time to make it a little simpler. And yes, there absolutely are shortcuts to this, and we'll talk about them when we get back. I just want to clarify one other thing. 2 to the 4th does not mean 8. 2 to the 4th means 4 copies of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. We don't take these two. There is multiplication going on there. It's just not those two numbers being multiplied. So 3 squared does not mean 3 times 2. It means 2 copies of 3, which is 9. Okay? Hope that video is under 5 minutes and hope that makes sense. See you all in class on Friday.